Good morning all. This is Satesh Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on linear time invariant system analysis using Z transform. Difference equation. It is an efficient way to implement discrete time systems. The convolution of input sequence x of n and unit sample response h of n gives output y of n is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. Two types of systems depending upon the length of unit sample response h of k. Finite impulse response FIR systems, unit sampled response or impulse response h of n has finite number of terms. Y of n is equal to summation k is equal to 0 to m minus 1 h of k into x of n minus k. Infinite impulse response IER systems, length of the unit sampled response or impulse response has h of n is infinite. Therefore, y of n is equal to summation k is equal to 0 to infinite h of k into x of n minus k. Recursive difference equation, y of n is equal to y of n minus 1 into x of n minus 1 plus 0.5 into x of n. X of n multiplied with 0.5 which is equal to 0.5 into x of n. Y of n multiplied with z inverse, we can get y of n minus 1. Again, x of n multiplied with z inverse, we can get x of n minus 1. That can be added with 0.5 into x of n. Recursive and non-recursive systems. Recursive system output y of n depends on present and past input as well as past output. Y of n is equal to summation k is equal to 0 to n into x of k. Non-recursive output y of n depends on present and past input. Right? Therefore, we can get x of n added with y of n. Y of n, we can get it as a one sample delay means z inverse. Y of n minus 1 that can be applied to x of n. Therefore, y of n is equal to y of n minus 1 plus x of n. Y of n is equal to summation k is equal to 0 to m h of k into x of n minus k. Z transform. Z transform is used for analysis of discrete time signals. It is more broad compared to discrete time Fourier transform. It is very much useful in discrete time system as well as system analysis. X of and x of z forms the Z transform pair. While we getting from the S plane, we can getting Z transform from transforming from S plane into Z plane with the help of ROC. System transfer function, ratio of the output to the input, h of z is equal to y of z divided by x of z. Frequency response, h of omega is equal to y of omega divided by x of omega. Condition for an LTI system to be causal, h of n is equal to 0 for n less than 0. Condition for an LTI system to be stable, summation k is equal to minus infinite to plus infinite. Modulus of h of k should be less than infinite. This is the Z transform unit circle ROC. When A less than 1 means outside of the inner circle is the A less than 1 ROC. 1 by A greater than 1 means inside of the inner circle and outer circle is nothing but ROC. A greater than 1 means outside of the second circle is nothing but ROC. 1 by A less than 1 means inside the circle of the first circle of the Z plane is nothing but ROC of unit circle. When x of z divided by a is equal to z divided by z minus a, and modulus of z should be greater than I means that it can be defined by a. The outside of the circle is nothing but your ROC. X of z is equal to z divided by z minus a, when z should be less than a means that it can be mentioned as radius a. The inner part of this unit circle is nothing but your ROC. How to find the impulse response? First, we can apply the difference equation, apply Z transform, finding the algebraic equation, solving for roots, and then for taking the inverse Z transform, we can getting the impulse response of the filter. This is the basic discrete time signal. U of n is equal to 1 for n greater than or equal to 0, 0 for n less than 0. Del of n unit sample response is equal to del of n is equal to 1 for n is equal to 0, 0 for n should be not equal to 0. Unit ramp signal can be defined as R of n is equal to n for n greater than or equal to 0, 0 for n less than 0. This is the graphical representation of discrete time signals. When pole 0 plot of linear time dt system means 0 means the values of z where p of z is equal to 0. The complex frequencies that makes the overall gain of the filter transfer function 0. Poles means the value of z where q of z is equal to 0. The complex frequencies that makes the overall gain of the filter transfer function is infinite. Therefore, x of z is equal to p of z divided by q of z. We can take in graph from real part to imaginary part, which is equal to r into e power j theta. It can be represented as unit circle. Linear time invariant discrete time system. How to solve the difference equation by using Z transform, by using shifting property of unilateral Z transform. Therefore, y of n minus 1 is equal to z inverse into y of z plus z into y of minus 1. Y of n minus 2 means z power minus 2 into y of z plus z inverse into y of minus 1 plus z into y of minus 2. Y of n minus 3 gives z power minus 3 into y of z plus z power minus 2 into y of minus 1 plus z inverse into y of minus 2 plus z into y of minus 3. Determine z transform of x of n is equal to u of n. X of z is equal to summation n is equal to minus infinite to plus infinite x of n into z power minus n. While we are applying the unit step condition, we can take limits from 0 to infinite 1 into z power minus n. By applying the values instead of n from 0 to infinite, we can get it as your z divided by z minus 1 divided by z the whole inverse. We can get x of z is equal to z by z minus 1 when modulus of z should be greater than 1. While we taking x of n is equal to del of n, while we taking z transform of del of n, we can get x of z is equal to 1. Therefore, condition is 1 for n is equal to 0. Next one, linear time invariant discrete time systems. Y of n is equal to 2 into 1 by 3 per n into u of n and x of n is equal to u of n. You can find the impulse response. While taking z transform, y of z is equal to 2 into z divided by z minus 1 by 3. X of z is equal to z by z minus 1. Therefore, y of z divided by x of z is 2 into z minus 1 divided by z into z minus 1 by 3, a by z plus b by z minus 1 by 3. While substituting the values, we can get a is equal to 6, b is equal to minus 4. Therefore, multiplied with z and taking inverse z transform based on ROC, we can get it as your h of n is equal to 6 into del of n minus 4 into 1 by 3 per n into u of n. Next time, linear time invariant discrete time system transfer function. For the difference equation, how to calculate the system transfer function. Y of n is equal to 7 into y of n minus 1 minus 12 into y of n minus 2 plus 2 into x of n minus x of n minus 2. We can apply the z transform. Y of z is equal to 7 into z inverse into y of z minus 12 into z power minus 2 into y of z plus 2 into x of z minus z power minus 2 into x of z. Y of z minus 7 z inverse into y of z plus 12 into z power minus 2 into y of z, which is equal to x of z we can take in as common z2 minus z power minus 2. Therefore, y of z we can take in as common 1 minus 7 z inverse plus 12 z power minus 2, which is equal to x of z is equal to 2 minus z power minus 2. H of z is equal to y of z divided by x of z is equal to 2 minus z power minus 2 divided by 1 minus 7 z inverse plus 12 into z power minus 2. This is the transfer function of the given difference equation. Now we can see the applications of Z transform. It is used to analysis of discrete time systems. It is used for digital signals. It is used to solve the difference equation with constant coefficients, to design the digital filter, to characterize the transfer function of linear time invariant systems. Now we can see the assessment. Define difference equation. Difference equation can be defined as y of n is equal to summation k is equal to minus infinite to plus infinite x of n into h of n minus k. Impulse response h of n has finite number of terms is called as FIR systems, finite impulse response systems. What is mean by recursive system? Output y of n depends upon present and past input as well as past output. Ratio of the output to the input is called as system transfer function. List the steps to find the impulse response. First, for the difference equation, we can apply the Z transform, and then we can get taking the algebraic equation, solving for roots, and taking inverse Z transform, we can getting the impulse response of linear time invariant DT system. Z transform of unit step signal is given as x of z is equal to z divided by z minus 1. List the applications of Z transform. It is used for analysis of discrete time signals, to design digital filter, to find the linear difference equation with the constant coefficients, etc. Name the condition for an LTI system to be causal means h of n is equal to 0 for n less than 0. Thank you.